Hi again. In my last video, I tried to give you guys an introduction to Hugin and sort of how it works. We stitched a couple of photos together. In this video, I'm going to show you guys one of my favorite features of Hugin, and it's sort of become one of my favorite features because I recently got a really cool fisheye lens for my camera. And it produces images that sort of look like this. Really distorted, but again, they have a really wide angle of view. This lens has a diagonal field of view of about 180 degrees. I think it's about 130 degrees horizontal field of view. But basically, you can take a panorama with this fisheye lens with 4 or 5 shots, potentially less, maybe 3 shots if you're really careful with the overlap. And of course, you may need to take 1 row for the top, 1 row for the bottom, but in any case, it's a really fun lens to use, but the fisheye effect kind of, it can get annoying. For some images, the fisheye effect works brilliantly, but for other images, you just want to capture a wide angle and you don't really want everything to be all fishy. So I'm going to show you guys how to use Hugin to get rid of the fisheye effect, or translate it into a different effect if that's what you're looking for. So let's get started. I'm going to start by loading this image into Hugin. So I'm just going to say load images, and I'm going to navigate to the folder where I have my images, and I'm going to select this fisheye image. Now it says that it can't find any lens data. Well, that makes sense because this new lens I got, it's actually a manual lens. It's manual focus, it has a manual aperture ring, and it has no electrical contacts with the camera, which means every time I shoot an image with this lens, the camera has no clue what sort of lens the image was taken with, so that information is not embedded in the photo. But I do know that it is a 7.5mm lens, and the software knows that my camera has a 2x focal length multiplier. Now, it's not a rectilinear lens. It's a fisheye, and it's not a circular fisheye. I believe circular fisheye in this context means that the lens creates sort of a circle image on your sensor. In this case, it's a full frame fisheye. It covers the entire sensor. So once I've input those parameters, the software realizes, okay, it probably has about 132 degrees horizontal field of view, and it has a focal length of 7.5 with a multiplier of 2. So that's good to start with. Right away, without adjusting anything else, if we go to the GL preview, we can see that something interesting is happening. The image is being puckered. It still looks fisheye, but the edges are sort of being distorted. And that's because of the default projection in software. I believe it's equirectangular. So if we go to the projection tab, we can see the field of view that it's showing us, as well as the equirectangular projection. So let's change this to cylindrical just to see what happens. So it changes it a little bit. Let's change it to rectilinear. And so it zooms all the way out and it gives a strange star shape. But what we can do is use these field of view sliders to sort of compress the vertical field of view. You can see the number up here changed. And then we can do the same with the horizontal field of view. And we can sort of see that already our image is a little bit unfisheyed. And that's a good place to start. But Hugin typically works better if you give it more parameters to work with. So one of the things we can do is that we can define vertical and horizontal lines in the photo, or simply just defining lines in the photo, and that helps it straighten things up, because you can see here that this line is still curved and a lot of the lines on the brick are still curved as if they were taken with a fisheye, even though this is much more straight than it was initially. So let's see how we do that. I'm going to leave the fast preview window open, and I'm going to switch back to the main window and go to the control points tab. I only have one image loaded, So the same image is being shown in both panes. And at this point, because I'm looking at the same image, we're in create line mode, not match control point mode. So I can turn off auto fine tune. I know that's not going to work very well for what I'm about to do. I'll leave auto add and auto estimate turned on. These two options basically mean that when I click, it's going to make a point, and when I click in the other window, it's going to make a point, and I don't have to say, yes, okay, I'd like to add that point. It just adds it instantly. So the first thing I'm going to do is establish a couple of vertical lines. So this fence post here seems like a good place to start. So I'm just going to click and drag, clicking and dragging, and get a little loop over my cursor, and I'm going to place it right there on that dark spot where the fence is. Now, Hugin zooms in and lets me see where I'm placing this, and I can click it again and drag it around to be more precise. I'm going to put it right on the edge of that fence post. Now, in the other image that's still zoomed out, I'm going to choose another point along that vertical line. So I don't want to go too far. I'm just going to go about halfway down the wall, click and drag, and release. Now, what it's done, I believe, is it's auto-estimated and it's gotten the estimation wrong. Or maybe it hasn't. But in general, sometimes you need to click again to place the point. So I think it's okay with where our point is. We got somewhat green on the match so far. It has a distance of 3, and Hugin has determined this is a vertical line. So what we can do is switch back to the fast preview. Nothing's changed, but we can go to the preview tab and say show control points. And that's going to show us the vertical line that we just defined. Well, things are still curved, but that's because we still need to optimize the image. Now, if you run the optimizer with too few control points, sometimes Hugin will sort of tie your image in a knot, and we don't want that. So I'm going to add a few more vertical lines so that we can make sure that we have enough lines. So right here, I'm going to add another vertical line along these sort of mortar grooves along the masonry itself. So I'm just going to click right here. Just going to reposition it so it's right in the groove, and sort of in the same spot over here, I'm just going to move down the wall, click down there. I kind of lost my place. If that happens, it's okay. You can always move the point. And then you click again to place the point. So I think I got it in the right spot. Yeah. And you can press 1 to zoom in. You can press 0 to zoom out. And if you're zoomed in after pressing 1, you can hold Shift and move your mouse to move both images, or you can press Control and move your mouse just to move one image. I'm not clicking here, I'm just moving my mouse. So now we have a second vertical line. Hugin is clever enough to see that we have sort of a vertical orientation and figures it out. Our image match has gone down to red, but that might not be a problem. So I'm going to add another vertical line. Let's add it also along the fence post, but not at the same coordinates where this one is. So I'm just going to click and drag, and then click down here, click one more time to create the point. And so if I go back to our fast OpenGL preview, you can now see the vertical lines that we've defined. I'm going to try to run the optimizer. It's a little unpredictable what will happen when I do it, but I hope things will work out well. If we go to the optimizer, I believe what we want to optimize are positions and barrel distortion. I think a fisheye is essentially just a lot of barrel distortion. Again, I'm probably not as smart as the guys who created this software, so I might be misunderstanding this, but I think that's how it works. Now we click Optimize Now, and it's either going to tell us that there's a bit of an error, or it's going to tell us there's a really big error and something went wrong. So let's see what it does. Optimize, it runs a couple of times, and it says, okay, I've finished, and it says all the control point distance differences are 0. Should I apply the changes? Now, the fact that it's 0 worries me a little bit, but let's just see what it did. So I press yes, and well, I don't think it was 0. I think just the position parameters were 0, because right here the pitch has changed, meaning the camera's looking more upwards or downwards, and the roll has changed. So it's used the vertical lines to sort of straighten our image. And let's see what it looks like in the GL preview. Okay, this is actually a lot better. if you'll notice, the fence post is now very straight, and our vertical lines here are lining up nice and proper. So I think in terms of straightening this image into an equirectangular image, I think we're okay. The next step would be to crop it, because obviously we cannot use this massive star-shaped image, which is sort of a rectangular image mapped around what a fisheye gives you. So let's go to the crop tab, and you see here that the crop is all the way to all of the edges. It's not cropped at all. And we can try the auto crop feature. Sometimes when I click this on my Windows machine, it brings the window that's behind to the front. So let's see what happens. Okay, it didn't do it that time, but it did successfully automatically crop the image. So now that we have this giant image here and the crop, we could probably save a little bit of memory during the stitching process by going back to the, well, actually we don't need to go anywhere. We can just move the slider so that the outside area crops a little bit tighter on the area we're going to use, and that's going to reduce the canvas size, I believe. Once we've reduced the canvas size, it sort of invalidates our crop, so we have to press the button again, and here it pulls the crop out to the size it should be. Now, one of the things you're going to notice right away is that because it's a fisheye lens, the pixels towards the edges lose resolution really quickly, because everything is sort of curved to begin with. They were actually, those pixels near the edge right here were actually much further away from the camera if you consider the sort of bulbous perspective. But I think we're done. We can actually stitch this image now. So I'm going to close the preview. We can go to the Stitcher tab. Again, we can say calculate optimal size. It went from 3000 wide to 9000 wide. So it thinks we need a much larger canvas to get the correct resolution out of that. It's still set to rectilinear. And now we can just say stitch. As before, it's going to ask us for a project name. So I'm actually going to call this RECT for rectilinear. I'm going to save that project file. And now it's asking me for an image file name. I'll use the same. It's going to save it as a TIFF per our settings. And we get the batch processor window opening. If you'd rendered a panorama previously, the window won't come to the front, so you'll have to go down to your taskbar or your dock and sort of click it to see what's going on. But we can see here it's just working on one image, so there's not a series of images it's dealing with, just one. And it's crunching away. It says it's on the stitching panorama step. This is after it's checked all of its tools to make sure all of the command line tools that it uses are installed. And here it's stitching the panorama using different settings for compression, low dynamic range. It's a TIFF. The output file name is rect. And image, I believe this is image index, is 1. And it's saving a temp file here in my temp folder. And it's just crunching away. Everything takes a little bit longer when I'm doing a screencast because my machine is already a bit taxed. And we can just wait for this to complete. Now, here in the batch processor, you'll see when it's done. It'll change from in progress to complete. Now, this is handling a 10,000 pixel wide image as the main canvas, and then it's going to crop our image in that, and it's probably just going to end up being a lot smaller than 10,000 pixels, maybe 3,000 or 4,000 pixels, which is closer to the native resolution of the camera I used. And it looks like it's almost done. It's just adding some comments about the image and what software it came from. And it's done. Remove the temporary files. The job says it's done in the queue. And if I go to the folder where that image is, this one right here, we can open it up in the photo viewer. Yeah, that's definitely taxing the machine. It's a big image. I think it's bigger than it needs to be. And here we have a fisheye image sort of warped into a rectilinear image, and the vertical lines are perfectly straight, and we've sort of, you know, we've taken a distorted fisheye image and made it straight in a certain sense of the word. Now if we zoom in, we can see a lot of the detail is still there. This was actually a really noisy image when I shot it, so that's where some of the low quality is coming from. This was shot at twilight. And you can see over here that as you get to the edge of the image, the resolution just falls off severely. And that makes sense when you look at the original image. Not this one. This one. You can see here that these pixels are actually really far away down near the edge of the image, so there wasn't much to work with there to begin with. This is the area with the sharpest focus. So that's how you deal with a straightening situation for a fisheye lens. But there's actually a variation on this technique that you can use even when your lens is not a fisheye lens. See here, I've taken a photograph of the same wall. It was actually taken at a different time of day, so the lighting is a bit different, but it was taken with my 20mm f1.7 lens set at an aperture of f8. So it's a pretty standard photo. 40mm in the 35mm equivalent scale, f8, 1/100th of a second. It's kind of a normal focal length lens, and it looks pretty straight. It looks pretty, rigid. But it actually does have a little bit of distortion in it. And this distortion comes from the way I was standing. I tried to be as head-on as I could be, but you can see here it's tilting a little bit. The left side is a little bit lower than the right side, and I might not have been completely perpendicular when I shot the wall. But let's say we were working in 3D. We wanted to use this as a source for a texture map we were making. We'd need to straighten it out, and we'd need to make sure it's completely square and completely aligned. So Hugin can actually help us with that, using a similar technique to what we just used to defish this image over here. So let's take a look at how that would work. Go back to my assistant, and I'm going to say new file. And I'm going to say load images, and this time I'm going to load in image 4551, the straight one. And this time it detected the lens. We didn't have to type in any parameters. It's a normal lens, 20mm, 2x multiplier. So it's a 40mm lens in 35mm equivalent math. And what we can do is we don't run the assistant, we don't run alignment. That's all disabled because there's just one image. We just go straight to the control points tab. This time we're going to define horizontal and vertical lines. And what that's going to do is it's going to give Hugin the information it needs to warp the image so that it's perfectly straight. I hope that made sense. It's going to warp the image so that it's perfectly straight. So let's start by just clicking and dragging here into the groove of the masonry. Alright, so right in the center of the groove, I'm just going to be a little bit rough. And then over here, right in the center of the groove. So that's the first line. It picked it up as a horizontal line. That's correct. Now I'm going to go to the other end of the image. Hugin likes it when you spread the control points around the image. So down here, right in the middle of the groove, and then way over at the edge of the image, right in the middle of the groove. So I'm just sort of arbitrarily choosing these control points. So I've got two horizontal lines. Let's do one more. Right over here, and then I think I'm on this row. Right here around the middle of the wall. So we have three horizontal lines now that sort of define the horizontal plane of this wall. Now let's do some vertical lines. It's a little trickier because of the brickwork, but I think we can bank on the fact that these bricks are lined up vertically pretty well. And we can just sort of click and drag, make sure it's right in the center, and then go all the way down to the bottom and make sure it's in the center. And I think, no, I messed this one up. Okay, this is a good example. I thought I was on this line here where the white stain is, but I was actually one over. So this control point is actually diagonal. Let's look at the OpenGL preview to see how to spot a mistake like this. In the OpenGL preview, again, it's showing it as a equirectangular projection. We can go to projection and change this to rectilinear, and it straightens it. Then we can go to the preview tab and say show control points. We can see the way I messed up this vertical control point. That is not a vertical line at all. That would ruin our next operation. So to fix that, pretty easy. I just press 1 to zoom in. Well, maybe not. It's too close. All I have to do is I'm on number 3, is I just click and drag, move it to kind of where I want it. Then I press 1. And I just fine tune it just to make sure it's in the center. I can then flip back to the OpenGL preview, and that is indeed a vertical line now. I'm going to add 2 more vertical lines, one over at the edge here and one at the far right edge. So I'm just going to flip back to the Stitcher window. And let's add a vertical line up here. I'm just clicking and dragging to create one, and then I'm going to create one down here. I just click and then click again to place the control point. I can click and drag the second time if I want, or the first time. Basically, these windows you can click and drag, or you can just click. Either one works. So that's a vertical line, and then one all the way over here at the far edge. It doesn't matter which window you start in. I'm going to start in the right window this time. So I'm going to start this new control point right here at the edge of the wall, and then I'm going to go down to the bottom. Let's not go so far down. Let's keep it within the bounds. I'm just going to click there, and now we have a vertical line. So if I go back to my OpenGL preview, I can now confirm that my vertical and horizontal lines are pretty much where they should be. Now this isn't unlike what you would do in Photoshop, except you would be kind of using the distort tool and manually transforming the corners of the image. And to be honest, when you do this in Photoshop, you introduce a lot of artificial distortion that shouldn't be there, that wasn't there to begin with. But this method should be a lot more precise. So we just go back to our multi-tab interface here, and we go to the optimizer. So now that we have control points, we can run the optimizer to sort of see what we want to optimize for. I think we want to optimize for positions and barrel distortion. So let's choose those and say optimize now. Okay, this is typical output from the optimizer window. It says it's done, here's the average, here's your standard deviation, here's your maximum. Do you want to apply the changes? The reason it gives you a choice here is because sometimes the results from this can be really extreme. And it's usually due to not having enough control points or too many control points clustered together. In this case, a maximum deviation of 1.8, that sounds fine. So I'm just going to say yes, apply it. You can see here it's adjusted the yaw, the pitch, the roll. And if we go back to the OpenGL preview window, you can see that it's slightly different. It's very difficult to see, but the image has changed a little bit. If you look at the left edge, you can see it curves outwards a little bit. Let me turn on the grid. Maybe that'll help you see. So here you can see the left edge curves out a little bit, and the top and bottom curve a little bit. But the important part is if we go to the crop tab, and we bring the crop boundaries in, we can actually bring them in to the border lines there, to the grooves. And we can see this image is pretty much perfectly straight at this point. We can go in and keep adding control points, but at this point I'm really happy with how straight the image is. And so we've basically examined the contents of the image and programmatically straightened it to the point where it's undoubtedly straight. And what we can do now is close the preview window. We can go to our Stitcher tab, ask it to calculate an optimal size. This time it went with 7,000 by 4,000 pixels, and then about 1,000 pixels at each edge of the crop. And we can basically say fit crop to images. We don't really want to do that in this case. You usually do that when you have multiple images creating a mosaic or a panorama. We can just double check the OpenGL window. It looks fine. And now we just choose our output format, our dynamic range of our image, and you just click stitch. So it's going to ask us for a file name, and this time I'm just going to call it barrel, because we kind of fixed a little bit of barrel distortion, and I'll just call it straighten. And we hit save. It's going to ask us what we want to call the image. Let's just call it straight. And it opened up the batch processor, but we can't see it. We need to bring it to the foreground. And there's another window here for the stitching progress. So again, it's going to work on this one image until it's done. See, this time it was a lot quicker because our file size wasn't as massive. Alright, now we can go to our folder where our new file is, and we can see here that this is the before image, and if we open up the after, you can see here that the after image is extremely straight on all the edges. The grooves here are like perfectly positioned. Whereas in the first image we were dealing with, it's kind of as shot. So if you wanted to use this as sort of a high quality source for a texture map, it would be a good idea to run it through Hugin first and straighten it, so that you can then take it into Photoshop or whatever your tool of choice is, and then work on it in there. So these are some of the things that I'm having a lot of fun doing with Hugin, because it's just such a cool tool to create some of these subtle effects on your photos that sometimes you want for style, like the way we defish the image, and sometimes you want for practicality, like when we straighten the crop. One other thing that's worth mentioning is the different projections that you can play with, but I think I'll do that in another video because this video is getting kind of long. And what we're basically going to do is we're going to take an image from a fisheye lens, and we're going to keep it as a fisheye image, but we're sort of going to play with a few of the different projections that are available. So I hope you guys enjoyed this video, and until next time, see ya.